Hey, hello everyone, good morning. Welcome to the C programming tutorial videos. So, in today's video, we will be discussing about different C variables, identifiers, and different functions like printf, scanf. But before going to what we are going to study today, let's just revise what we had done in the previous videos. So in the first video of this programming tutorials, we understood what programming was, what was the program, we understood what binary system is and why we used binary basically for any computer programs, and why only binary is understood by the computer. Other than that, we also classified the languages into different generations and understood why C is high level language, how a compiler is different from an interpreter, and also wrote a C program. So before writing a C program, we also installed a IDE to our system to code. So an IDE is a tool that we use to code. So other than that, in the next video what we did was we understood about the C program structures. What were the different parts of the C program? It were the comment section, the pre-processing section, the global declaration part, the main part, and the main part consists of two different local declarations and the execution part. So all these were the part of any C program. We understood how we could write the comments in our C program and why comments were necessary. So as these comments, they are an optional part of the code, but it's necessary if you want to use this code again and again for our future reference. In future, whenever we are going through any code, so we would be able to understand like this is the function written to do this, and we can optimize it or we can do something like that. And then that what the preprocessors were, we discussed that. So what were the preprocessors? They were the system program that performs the pre-processing of the high level language. There were three basic functions that the preprocessor does on a high level language code. What it does? First, it removes the comments, it includes the file, and then it does the macro expansion. So whenever a C program is fed to a for compilation, what is the different steps that it goes through is, it first goes to the preprocessor, a high level language code, then a preprocessor does these three steps. After that, it goes to the compiler. The compiler then compiles and make an object file of that object file is then sent to the assembler, and then assembler changes into sends it to a loader or linker, and that is then converted into zeros and ones, binaries. So these are different steps that is being performed before any language is translated into low level language, and then back the output and before giving the output. So why are these different steps used? Because it just makes it easier to understand. So any of the preprocessor of different languages can be used, and they all perform the same type of things. If we use our interpreter or compiler, they use the same thing. They just converts the high level language to low level language code. Okay, so these are the different, like what we can say are the standards being followed that makes the work easier for programming. Okay, so we also saw different types of uh, preprocessor. Okay, so these were the hash define. What it does, it substitutes a preprocessor macro. So we wrote a preprocessor macro to add two numbers. Remember, we defined our addition code in the after std whatever the inclusion files, and that we called in the main function, and what it did, it used that macro and calculated the output of two numbers and added two numbers, and it gave us the output. Okay, so these were the different things that we did in the last video. So let's now focus on today's contents. Okay, so today first we will be discussing about the printf and scanf statements. Printf and scanf we have used in the previous codes as well, but let's just understand what are they. Okay, as I have previously also said, they both are the part of stdio.h header file, and they are predefined functions of C. What they do, printf just prints anything on the user out desktop or screen, and scanner, it takes the input from the user. So if we define it, printf is a predefined function in stdio.h header file, and by using this function we can print the data or user defined messages on console or a monitor. While working with printf, it can take any number of arguments, but first argument must be within the double quotes. Okay, and every argument should be separated by a comma. Within the double quotes, whatever we pass, it prints the same. If any format specifiers are there, then that copy the type of value. Okay, so let's see what it does. So let's see this. In this program we have a printf statement, right? What it is doing is printing the statement enter first value. So as we had discussed, any argument should be between the double quotes. Here it is. So by the syntax of C, it should always be ended with the semicolon. We have put a semicolon to that, and we have called this function printf and just printed this message. If you want to print any other message, what we can do is printf within the double quotes any statement, hi, I am snicked. Okay, so if you will compile this, you just say build and run, what will it do? It will print two different statements. Both are just messages on the C. As you can see, enter first value and hi, I am snicked. As we have not defined any next line, so compiler has just printed it without any space or anything. If you want to print this in the next line, what you can do is just put slash into that. So after this, if you put slash n, what it does is it defines the end of line. Okay, so if you put slash in here and then just print this, what will it do? Just put say build and, as you can see, now both of the lines are printed in the different lines. Okay, previously it was in the same line without any space or even the next line. So when we put slash in, it printed in two different lines. Okay, this is how we format this. It's good for our understanding. Okay, also we had seen that we have printed values, integers. So if we see, I have commented this line of code. If we see, we have printed this C value. Okay, so we cannot just say print C and it will print C whatever value is it. We need to tell the compiler that we want to print a variable, and for that we use format specifiers. So let's understand what format specifiers are. Format specifier is used during input and output. It is a way to tell the compiler what type of data is in a variable during taking input using scanf or printing using printf. For example, %d is a format specifier for integer type of value. %f is for float, %lf is for double, and likewise if you want to print a single character, we need %c. So for string, if we define a string value, we need to specify that as percentile s. Then only the compiler will understand that it is that you want to print that variable. Otherwise it will just bluntly print that whatever you say. If you want to print the value of c, we need to specify it that you want that you need to particularly print the integer. So let's understand what I said through code. So these are the statements, right? If you just want to print this variable c, let's just uncomment this in c and assign c with a value, let's say 5. Now c has a value of 5. If you want to print c, what you need, if you just say printf c, what will it do? Let's see. It just prints the value c what we have written. So if you want to print the value what is contained in c, what you need to do is just define the identifier for that. So as it is an integer, and we had seen that for an integer we need the format specifier is %d. So what we need to say, the value in c %d comma c. Okay, now what will it do? We have just defined this format specifier %d and we are printing c. So if we now compile and run this, what will it do? Print the value inside c. So let's see what's the output of the program. As you can see, the value in c is 5. So previously what it printed out was c, and now it has printed out 5. If you just remove better to for the understanding, what I will do is just remove this line of statements and just put %d and the value. Okay, as you can see, it is printing 5. What is 5? 5 is the value that is contained in c, as we have defined in c, and c is equal to 5, and 5 we are printing. So likewise, if you want to print any character or any other double value or string value, we need to just define the format specifier accordingly. Okay, so next part. So instead of using %d, we can also use %i, right? So if you just see this, just put %i in instead of %d and the variable, it would again compile and give you the same output. Let's just comment this line. Okay, compile and run. The same output. Okay. So let's discuss what exactly is the difference between %d and %i. Okay, so %d assumes base 10 while %i auto detects the base. So both specifiers have behaved differently while they are used with input specifiers. So if we define that %d takes integer value as signed decimal integer, that is, it takes negative values along with positive values, but values should be in decimal, otherwise it will print garbage value. %i takes integer value as integer value with decimal hexadecimal or octal type. To enter a value in hexadecimal format, value should be provided preceding with 0x, and value in octal format, value should be provided by preceding at 0. Okay. Similarly, for float variable, what we will do, just define a float f for example, and print that. For float we need a access specifier as percentile f. Put here f equal to 1.5 for example. Just run this code. As you can see, 1.500000. So 1 2 3 4 5 6 places of decimal. It shows 6 places of decimals after the decimal point. Okay, now if you similarly, if you want to define a string value or a character for it, first let's see a character, char ch for and ch equal to q. Okay, so if I'll show you one thing here. If you put here percentile c and ch, let's just remove this line of code. What will happen? It is giving you an error. Okay, so why? Because whenever you define a character, you need to specify it within quotes. Always remember that. So this is a character, you need to define it as inside the quotes. Here what you see is error q undeclared. Okay, so whenever you see this type of errors, it means that you have not defined any character or string in the quotes. Whenever you define that, you need to define it between the quotes. So now if you run after adding inside the quotes, that will not show any error and it will compile. As you can see, it has now compiled and the output will be, as you can see, q. Okay, so what if you want to print some special characters like percentile? How will you print it? Let's see. There's a simple way to print the percentile. As we have seen, the printf statement works. Whatever you write it inside double quotes, it prints that, but it doesn't work for this format specifiers or a keyword or anything else like that. So if you just put percentile inside the double quotes of a printf statement and try to build and run the code, what will happen? It will not give any output. So if you want to print this, what you can do is put 2 percentage signs here, and now just build and run. As you see the output, there is 1 percentage here. So printing special patterns is one of the competitive questions or interview question that you may face. This is one of them. Maybe you could be asked to print percentage. So how you can do it? In the printf statement, put 2 percentage sign. You will be getting 1 percentage. There is another way to print this. If you just put percentage c comma percentage inside the double quotes, and then build and run this code. It will again print the percentage sign. So these are two different ways you can print a special character. Okay, so now let's see for the scanf statements what scanf does. Scanf, as we have previously also used, is a predefined function in stdio.h header file, and it can be used to read the input values from the user. Okay, so whatever you want to fetch from the user, like you want to compute area of a triangle and you want to take the inputs length, breadth and height from the user, we can use the scanf function. Okay, we have already seen how it works, so let's see it again once more. I love using this IDEs because they're smart and you don't have to write much of the code. So before writing a scanf, what we need to define is a variable a, for example, right? So %d, ampersand, this will be scanning the input. To show this input, we can add a printf statement. Printf the value %d, comma a. Let's build and run this code. Enter some values, for example 24. So the output comes, the value is 24. So what we are doing is taking an integer value from the user and printing it out. So to make this more readable, let's have a printf statement before too. Enter a value to show on the console. Okay, what I am doing is this line will be just showing us the it will prompt on the screen, that from that we will be understanding that it's asking us for an input. Okay, so now like this we can just scan the user input and just show it on the output console output. So what if you want to show your name on the screen of your computer? What you want to do, how you can do that? So for that we need to define a string. What's a string? String is a sequence of characters or a combination of characters. So we will define a character string like this, character name and with the size of that. Okay, this means that this is name is a 10 spaces long string. Okay, so how, and for if you want to scan that, it should be %s and name. So this bunch of code will input your name. You can input your name and it will show you your name on the computer screen. So let's build and run this code. It asks for your name. You can put your name. My name. I put my name in here. As you can see, the console output is there with my name. So likewise, let's just write a program. So what if you want to enter your name and age both? For that, what you need to do is define another variable int age. Okay, here put %d and here ampersand age. Okay, and if you want to print it, you can your name is here and write another line. Okay, printf, and put this in next line. Your age is %d, comma, age. Name and age. So now let's build and run this code. So it's asking for your name and age. Just put your name and your age. As you can see, it's formatted that, and it's giving your name and your age. So in this way you can take multiple inputs from the user and do whatever you want. Do multiple applications. If you want to make a calculator for adding something, you can take multiple inputs like this in console inputs and then formulate it and produce the outputs likewise. Okay, now basically we have understood how we can take multiple inputs or take inputs from the user and print it accordingly what use we have. So now let's move forward with the next topic. So the C language has reserved some of the words for its internal use, like and they are known as keywords. So what are keywords? Keyword is a predefined or reserved word in C library with a fixed meaning and used to perform an internal operation. Altogether, C language has 32 different keywords. As you can see on this computer screen, these all are the keywords of C. Every keyword exists in lowercase letter like auto, break, double, and all. You can see all these 32 words all are in lower cases. So what does these keywords do? They perform a particular task. Like if you say the for is a keyword that is used for defining a loop, for loop. If you see other character, char, we have used this keyword, and this is used for defining a character in any variable in C language. Likewise, int, long, these all are keywords and these are used for defining some of the characters. If you see, we have also seen this return keyword in our code. The return keyword, what it does is returns the control of the code to the previous call. Okay, if for example, if we have defined a function, user defined function other than main, and we are calling that function from the main function, so this return when the code will be running and the control will be in that user defined function, this return keyword will be returning the control to the main function. Okay, and then the further process will be executed and the output will be given to us. Likewise, if you see the float is also a keyword, and that is used to define a floating number. What are floating numbers? They are basically the decimal point numbers, is what you see. Okay, so all these different keywords, we will be dealing with every different types of keywords in the further videos. So what we need to discuss next is identifiers. What are identifiers? So identifiers are the names given to different names or entities such as constant, variables, structures, functions, etc. As we discussed in the videos, C program has different parts, and for every part we must have an identifier. For example, if we are defining a variable called age, that age is an identifier. We are defining a user defined function, calculate sum, so that calculate sum is an identifier. So what are the rules for naming the identifiers? An identifier can only have alphanumeric characters. it can be small a to small z, capital A to capital Z, 0 to 9, and the underscore symbol. These are only things that we can have. It cannot have special characters like percentage, exclamation mark, ampersand. These type of words as special characters are not allowed to define a C identifier. Okay. The next rule is it must be unique. If you have defined an identifier for one thing, it cannot be reused. Okay, or otherwise it would be repopulated with that, and you cannot use the previous word. The first character must be alphabet or an underscore. This is very important. It cannot be a number. Whenever you define an identifier, the first character must be alphabet. Okay. You cannot use, as we have seen, the 32 keywords. Those 32 keywords cannot be used as identifiers. Okay. And most important thing, if you write your name like Ram Singh, it cannot contain a space between it, because it will be taking us different alphabets. Okay, and it will be giving you an error. So if you want to write an identifier with Ram Singh, there should be an underscore you can put, or just remove the space between them. Okay. And the most important thing, one more thing, is identifiers are case sensitive too. These identifiers, if you write some smaller characters, you have to copy that word by word if you want to reuse that somewhere, right? So these are the different things required if you are making a C identifier, defining a variable or defining a function. Let's just see in the code what are different identifiers. So this main, what you say, this is an identifier. If I am defining a character with ch, this ch is also an identifier. If all of these things are identifier, if you want to, as we are discussing, we can see if I put one ch and try to build this code, it will be giving this error that there is some error in the code. So as I had said, we cannot start with the any identifier with a number or any if you want to just add a special character @ and try to run, this will be also saying an error that this is not allowed to do in C. Even if you add this after ch @ this will be not allowed, but if you add the number after ch and then run this code, it will compile. Okay, so basically I have only I'll be commenting this lines, then it will be visible to you that it doesn't have any errors. Now let's compile this. See, as you can see that you can compile this. This is a valid identifier. Even if you want to add an underscore after this, this will be a valid identifier. You can also start a identifier using a underscore. Put underscore before this. Okay. See, this is building, no errors in the code. Even if you want to just add a an underscore can also be an identifier. Just compile this. There is no error in the code, so you can define an identifier with underscore too. Okay, so now these are different things for identifiers. Now let's write a code to print the ASCII value of any of the numbers. So what do you understand by ASCII values? The character data is represented in a computer by using a standardized numeric codes which is known as ASCII. ASCII stands for American Standard Code for Information Interchange. The ASCII codes associates an integer value for each symbol in the character set, such as uh, capital letters or small letters. Everything, they have a particular number, integer associated with it. For example, if you see the alphabet, capital small a is represented as 97 in the ASCII. Likewise, small b is 98 and it's incremented thereafter. 99 is for small c, and this is all what ASCII values for different alphabets is. So let's see how to print the ASCII value of any character. Okay, let's just remove this code. So I'm defining a character ASCII. Okay, so let's take the user input. So before taking the scanning, I'm just printing it on the console. Enter the alphabet to show its ASCII value. Semicolon. Let's scan this value now. Scanf percentile C, as this is a character, and ampersand ASCII. What this will do, this will be scanning this character. Now let's just print the ASCII value. So for printing the ASCII value, what you need to do is, it's very straightforward. Just put percentile D. So percentile D in identifier is used to print the integers. So what it will do, it will be printing the value of ASCII character value for the characters you are trying to print. Let's just print a line also. The ASCII value is ASCII value is. Okay, let's put this in the next line slash n. Now I have put all the semicolons. Let's just go to go. Let's just build and run this code. Small a, as you can see, the ASCII value of small a is 97. Let's see for small b. Put b, it's 98. Let's see for capital A what it has. Capital A, it's 65. Okay, now let's see for capital Z what it says. For capital Z, the ASCII value is 90. So these are the different ASCII values for different characters that we have. There is also an ASCII character associated with space. So let's see what's the ASCII character for space, the integer, what integer value is there. So I'm pressing space here. It has scanned space. Now it will be showing that. So the ASCII value for space is 32. So these are the different ASCII values for different characters that we have seen. So for special characters also there are some ASCII values. Let's see for percentile what it gives us. It's 37. So likewise there are different ASCII values for different characters and integer values associated with different alphabets and special characters. Okay, so in this way you can print the ASCII values of any of the characters. This is a very common question asked with from any fresher in the interviews, to print the ASCII value of any integer or any value. So it's very a straightforward code. So you need to just print the percentile d with the percentile d specifier, you can print that character and it will be showing you the output. Okay, now let's move to the next topic. C variables. What are variables? A C variable is a named location in a memory where a program can manipulate the data. This location is used to hold the value of that variable. The value of C variable may get changed in the program. C variable might be belonging to any of the data type like int, float, character, etc. So basically what I mean to say is, there is a particular location in a drive or hard drive you say, and that location you just name it with a different identifier. If I say the jargon, it's identifier, and that's if you want to place a name like define a variable called name, and that name is basically a space in the hard drive, the memory, and that will be contained inside the variable. Okay, so what are the rules for naming a variable? So variables must begin with the letter or underscore. It's same as that of the identifier. All the rules are the same. They are also case sensitive. They can be constructed with digits or letters. There are no special symbols allowed other than the underscore sign. Like for example, some height underscore value are some of the values for variable name. Other than that, we have used age, name, integer, whatever you can use to define a variable. Okay, so what let's understand declaring and initializing a C variable. A variable should be declared in the C program before we use it. Like if you want to take input of age of the user, so you have to define the age. Okay, need to declare the age, int age. Okay, that int age will be storing the value of the age of the user. Fine. Memory space is not allocated for a variable while declaration. So if you say int age, at that point of moment there is no space allocated to the variable age. It only happens when the variable is defined. Okay, so variable initialization means assigning a value to the variable. So when you initialize means when you say int age equal to 3. So this statement will be assigning a value to the variable, and at this moment 3 will be associated with the age of the user. So there are some basic things that you need to remember when you're using variables. Variables should be declared in the C program before we use it. The memory that is not space is not allocated for a variable while declaration. It happens only on variable definition. Variable initialization means assigning a value to the variable. That means int a equal to 5. In this way we are assigning a variable. Okay, if we just say int a, that is variable declaration, and if we say int a equal to 5, that is variable initialization. So there are 3 types of variables in C program. What are they? They are local variable, global variable, and environment variable. Okay, so what are these 3 types of variables? Local variable, the scope of local variable will be within the function only. These variables are declared within the function and cannot be accessed outside the function. Okay, so let's understand programmatically what are local variables. So for that I will have to define a function that other than main, which will clear you how local variables are used. So let's define a variable a and assign a value to it. Let's say 12, b equal to 13. Okay, now printf values a equal to %d and b equal to %d. Okay, what will this do? This will just print a and b values of that. So now let's just define another function called test. The void test. Int x equal to 5 comma y equal to 6. Printf value x equal to %d and y equal to %d x comma y. Okay, so as we have made this function, we have to just tell the C program that we have another function called void test that is defined. Okay, so now what we are trying to do in this is, let's see the scope of the local variables. Okay, so here let's call the test function. So basically what I'm trying to explain in this program is the scope of a and b is within this main function only, and scope of x and y are within this. So if you try to access this x and y in int main, now let's debug this, run this program and check what's the output, and then we will discuss about the scope. As you can see, the values are printed here. So it has printed the value of a, b, x and y. Okay, so they have been printed as per their scope, but if you try to access these two variables, like if you define a value int sum after calling this function and you try to add a plus x. Okay, since we have defined this values, so it must add, but let's see what happens. Printf sum is %t comma sum. Now debug this code. So what does this say? X is undeclared, but we have defined this function x value of x here in the void test, and we have also called this. So what is happening here? So this is actually what is the scope of the variable. This x will only be available to you within this function, and if you define it and try to access this value here, it will give you an error. So these are what we call the local variables. Okay, so now let's see what are global variables. So as we know, the scope of global variables will be throughout the program. These variables can be accessed from anywhere in the program. So how we define this? Global variables, these are defined outside the main function so that they are visible for all throughout. Okay, as we have defined the void test after the calling of standard libraries, these global variables also need to be defined there. So let's define int x here, x equal to, let's say 20. Okay, so as we have defined x once, so let's say it's m equal to 20, and let's try to access a plus m. What I'm trying to do is trying to add value of a to m. Let's run this code. So as I have defined m here last time, and when I tried to access x, it was giving an error. So let's see what happens when I try to debug this. And so it doesn't give me any compilation time error, and it executes. So let's see what's the result of the code that I have written. So as you can see, the values are printed, the value of a, b, x, y, and sum is 32. As we had defined the value of m to be 20, so it has been added. So sum is equal to 20 plus 12, that is 32. So it is being able to access this. Now let's try to access this m value in this function also. So what I will do a negation, subtraction, as you say. Let's say int sub is equal to m minus x. Let's print this. Printf the value is %d comma sub. Here again we were not having any errors during the compile and run, so this will be compiling and giving us the output. So as you can see, the value is 15. So what is the value of m? M was 20 and minus 5, it is 15, so it is giving us the value 15. So why it has been printed here? Because what is happening here, when the execution starts, it starts from the main function, and then it will be executing this statement, again this statement printf. So it will be, as you have seen, this value was printed on the screen. Then it calls test. When it calls test, it will be executing the statement and then printing this statement. So in the end of the code, you will be having the value of the sum. Okay, let's see it again, how it printed. See, the first printf statement was value of a and b. Okay, so a was 12, b was 13, we got that. Then we had called the function test. So in test, the next printf statement was the value of x and y. So we got the value of x and y. Again we had printed in test function printf sub. So the value of sub was printed here. After that, when this function executed, the control was returned back to the main function, and now we have the sum, and we printed sum. So the sum was printed, sum was 32. So this is how the program executes for any of the subroutines or calls. What happens is, whenever you execute the program, the execution will always start from the main, and it will initialize all the values and call all the functions. So if you are defining any function other than main, you have to call that function in main. Okay, so let's see what we understood in this video. At first, we understood the printf and the scanf functions, what they were used for, what were the format specifiers, and how we could print different types of values like the integers, the characters, strings, how we can take input from the user and use that input to manipulate it and use as per our use, whatever we need to do, we can use that. So after that, we understood about the different keywords, what keywords were. We also understood that there were 32 keywords in C, and these keywords cannot be used for other purposes, and there is a specific function for every keyword, and we use that for that purpose only. Like an int keyword is used to define an integer, same as the char is used to define a character. So we cannot use this char as a variable in the C program. It will be giving us error. We also saw a program in which I showed you how we could see the errors and then understand the program and debug it and rewrite the code, removing those errors. We then saw what the C identifiers were, and what are the different naming conventions, or what we can say the rules for the identifiers, when how we can make a identifier. So we also understood about the C variables, and any variable like is what it is. It's just a location in the memory of the CPU. So that memory we give a name, and we can use that for our storage purpose. Like we can use an integer a in the for addition, subtraction, or furthermore, if we want to use it in other functions, we can use that location a for different purposes. So we then understood what is the basic difference between the identifiers and the variables. What were they? So identifier is anything that defines, right? A function name is also an identifier. Any name that we use in C is an identifier, whereas a variable is basically a memory location. Like int a is a variable. It is also an identifier, but it's a memory location basically. Okay, so these were the all things. After that, we wrote some of the programs to understand how we debug the code, what is the scope of the variable. We saw what were the global variables, what were the local variables. We wrote a program to understand the scope of local variables, and we also understood how the execution of program happens. Like it is always starting from the main function. The main function is executed first, and then it goes to the other function that we call. We wrote a program, and we understood how we can use a local variable in the scope of that function only, and we cannot use that local variable in other functions, right? When we tried to access that local variable, we got an error. Other than that, we defined a global variable and then we wrote a program to subtract and add that in different functions. So the global variable was available in all of the function that we had written. So these were the different things that we did, right? So in the further coming videos, we would be understanding what are the different storage classes, what are the data types of C, and we will be talking about different programs also.